How's it going, Math 1 people? This is lesson 5.3, maximum, minimum, and intervals of functions. In Khan Academy, we are still working in Unit 8, titled Functions, and this lesson will cover skills 14 through 18. Your objective is that you should be able to identify maximum and minimum values of a function. You should also be able to identify increasing and decreasing intervals and positive and negative intervals. The key word is intervals. We've used intervals before, so this is just a review, but an interval is a set of all real numbers between two specified endpoints. So when we were writing out a function's domain or range in the last lesson in 5.2, we listed intervals. In fact, the first example in our previous lesson had this domain here. We wrote it as an inequality, a compound inequality. X could be anything between -6 and 7. In that video, I only used inequality notation, but I do want to point out that you could also use interval notation. It saves a little bit of time and it's a little bit less writing. So if you want to refer to this interval, you can write it using these square brackets. And the square bracket just means that you're including the endpoint. Because there's a greater than or less than or equal to, we're including that -6. So if you wanted to change this a little bit and maybe not include the 7, all you would have to do is switch that bracket to parentheses to show that the 7 is not included in our interval. You could even choose to exclude the -6 as well. So this blue interval would be referring to all the numbers between -6 and 7, but not including -6 and not including 7. Be careful with this. Use context to tell if it's an interval or if it's just an ordered pair, like a point that you could plot on the XY plane. Okay. So next we're going to talk about maximum and minimum values. The first blank should be relative, and we're talking about more than one, so this should be plural. You can cross that out and say relative maxima, which is the plural for maximum. Relative maxima are the highest points on a graph. Similarly, relative minima are the lowest points on a graph. So I have marked the relative maxima here in blue. And just to point out, we are assuming that the function is only defined here. So there's nothing going to the left of when x is -10. There's nothing going to the right of when x is 7. So this point is a relative maxima because it's higher than all the points on the function immediately in its area or in its neighborhood, because all these points to the right are lower than that point, -10, 6, and there's nothing to the right. I'm sorry, nothing to the left. This point here is also a relative maximum, because it's higher than the points around it. Same thing here, 4, 8 is higher than the points immediately to the left of that point and immediately to the right. Relative minima are these ones here. And again, they are relative minima because they are lower than all these points near it. Okay. In contrast to relative maxima and minima, we can have what's called absolute maximum values or absolute minimum values. And I use the singular here, an absolute maximum. We're using the singular because there's only one. It's the highest point on the graph. The absolute minimum is the lowest point on the graph. So this is the same graph as before. Even though there were 3 relative maxima, there's only one absolute maximum, and that's this one here. Same thing for the minima. There were 3 relative minima, but only this one is the absolute lowest. That's the lowest point on the graph. Okay, so now we're going to talk about positive and negative intervals. Positive intervals are when the y values are the points where the y values are positive. So on our graph, all of these points here that I'm highlighting in blue have positive y coordinates. Negative intervals are intervals where the y values end up being negative. So all of these points that I'm marking in red have negative y coordinates, right? Except for maybe right here and right here. Those points have y coordinates of 0, and that's not positive or negative, right? So let's talk about the positive intervals. In fact, there's just this one. So when we're talking about the interval where f of x is positive, we're listing it's an interval of x values, right? So when x is 1, that's when the function starts to have positive y values, and it continues to have positive y values all the way up until when x is 4. Notice I did not include the endpoints. I didn't say less than or equal to, because when x is 1 and when x is 4, the function is not positive, it's 0. You could also write that in interval notation, just like this, using parentheses. All right, so I want you to try the second part on your own and come back and check your work. Can you write an interval to show that f is negative here, and then write another interval to show that f of x is negative here? All right, so you should have written this interval, -5 all the way up to 1, but notice that we can include -5 because when x is -5, our y coordinate, our output, is still negative. Same thing here. We're not going to include the 4, but we can include the 5. So we have our two intervals. You don't have to write both. You can choose to write inequality notation, or you could choose to write interval notation. Either way is fine. And then last, you should be able to tell when a function is increasing or decreasing. So within the given domain of the function, when the line is trending up, then it's increasing. And if the line is trending down, then it's decreasing. So we're just going to trace the function starting starting here. It's going down, right? Remember, we used this analogy before, but imagine like those side-scrolling Mario games. He runs from left to right. If he's walking on this ground, he'd be going downhill all the way up until here. And then he'd be walking flat for a little bit. But then after that, now Mario's going up the hill. That's an increasing interval all the way up to here. And then he's going downhill again. So that'd be decreasing again. All right, so if we need to write that in interval notation, it looks like Mario starts having to walk uphill at about -1.5, and it's positive, it's increasing all the way up until 1.5. There we go. And then the intervals where the function is decreasing, it looks like it starts at -5. Oh, let's write it in red to color code it. And Mario would be going downhill. The function is decreasing all the way up until -1.5. And then this last one, go ahead and try this one on your own. Come back and check your work. There we go. Starting at +1.5 and all the way until the end at 5. All All right, that is lesson 5.3. As always, ask a question about anything you've seen in the video or make up a practice problem, and I will see you all in class.